Hello students, I am Satitrakar. Welcome to Cars Physics. This is my lecture 8 on kinematics and we are continuing motion in a straight line. In this lecture, in lecture 8, we will discuss the derivation of kinematics equations. Okay, but one thing we know, we are continuing kinematics but motion in a straight line. Number one, our basic assumptions to derive those equations are: number one, motion of a body is in a straight line. Number one. Number two, body is moving or the body continues its motion with uniform acceleration, means with constant acceleration. And as we know, when a body moves with uniform acceleration, then velocity changes equally in equal interval of time. Okay, all these equations are not valid for variable acceleration or for non-uniform acceleration. Okay, before going to the derivation of the equation, let's first assume a body is moving along a straight line. Okay, body is already in motion, but when we start observing, we have taken instantaneous time is 0 when position of the body is 0, means along x-axis position of the body is 0. We have taken t is 0, we have taken position is 0. This is our fundamental assumption. And v naught is initial velocity of the body when time is 0, means instantaneous time is 0 when velocity is v naught. A is uniform acceleration of the body. Okay, let when time is t, body starts from position A. When t is 0, when time is t, body reaches at position B, and at this position v is velocity. We are taking v as final velocity at time t. Here time is 0, initial velocity v naught, when velocity is v, time is t. See students, body has position 0 when it is at A, and position of the body is x when it is at position B. The change in position means x minus 0 is x is displacement, or in this case you may say x is position coordinate. Okay, so x is either displacement or position coordinate. Okay, these are basic assumption. Then we will move to our derivation. But the fundamental concept we have already discussed: velocity, acceleration, speed, etc. And as we know, acceleration is defined as time rate of change of velocity, or simply speaking, acceleration is ratio of change in velocity to change in time. Since the body moves along a straight line, let acceleration is uniform, A is uniform acceleration is between the positions A and B. Change in velocity is v minus v naught, change in time is t minus t naught. Okay, so without using vector subtraction, we will write directly the magnitude of acceleration is v minus v naught divided by t minus 0. The change in velocity is v minus v naught, means magnitude of acceleration is v minus v naught by t minus 0. This is possible when the body moves along a straight line. Otherwise, the result of vector subtraction would be different. Okay, angle between v naught and v is 0. So v vector minus v naught vector means the result of vector subtraction, means magnitude of vector subtraction is v minus v naught. Okay, then we got acceleration is v minus v naught by time. So v minus v naught is 80, and final velocity is v naught plus 80. This is our first equation. I am writing here equation 1. V is equal to v naught plus 80. B is final velocity, V naught is initial velocity, and A is uniform acceleration, and T is time taken by the body, or T is interval of time. Okay, can I erase all these things? This is also required. Acceleration is V minus V naught divided by time from this. Okay, we have got equation 1. Then see students, the equation what we got means relation between initial velocity and final velocity. V is equal to V naught plus 80. This equation is equivalent to mathematical form y is equal to mx plus c. V is equal to 80 plus V naught. So in place of Vy, mx 80 plus c V naught. V naught is initial velocity which is taken to be constant. Okay, so V is equal to V naught plus 80 represents equation of a straight line. Now represent in the required graph. Along x-axis we are showing variation of time, and along y-axis we are showing variation of velocity. Okay, when instantaneous time is 0, velocity or initial velocity of the body is V naught. So this is V naught. Thereafter, velocity increases since the body is moving with acceleration. So now this is equation of straight line, V naught plus 80. So this is our straight line, velocity increases and final velocity is V. Okay. Time taken by the body is from 0 to t, from 0 to t. Okay. See students, if initial velocity, if V naught is taken to be 0, means if the body starts from rest, then this graph would be like this. This is velocity, this is time, and initial velocity is 0, means V naught is 0, then the straight line, the graph follows a straight line path, V is equal to 80. We'll discuss all these things, means different forms of graph we'll discuss in coming lectures, and also we'll discuss how to approach numericals in very easier form by using kinematics graph. Okay, let's wait. Then now, this is the graph. Again we know, you know it. I am writing the concept. Distance. See students, if a body moves along a straight line, then magnitude of displacement is equal to distance, or magnitude of velocity is equal to speed. Okay. Distance traveled. Here body is moving along a straight line, so magnitude of displacement is distance. Distance traveled can be calculated by calculating area under velocity time graph or VT graph. Okay. Here we have the graph between velocity and time, and this is the graph, means variation of velocity with time, which is a straight line. To know what is distance traveled by the body, see, the body starts when position is 0, and at position B, position is x, means displacement is x, means magnitude of displacement is x. Okay, so we can calculate x by using the graph. Okay, we have to calculate the whole area under the graph, but this graph can be divided, means the area can be divided into two parts by drawing a perpendicular from this position. See, up to this is V naught, from 0 to V naught. This is V naught, this is V, so obviously this is length is V minus V naught. Okay, then total area can be calculated by calculating the area of this rectangle plus adding area of this rectangle and area of this triangle. We can get distance or displacement of the body along x-axis. Okay. Now, distance traveled by the body x or along a straight line, this is magnitude of displacement also. X is equal to area under VT graph. Okay. So, area of rectangle, see students, base from 0 to t, means It is t, it is length. Length is t, breadth is v naught. Then this area is v naught into t, breadth into length. Area of rectangle, we have to R. Area of triangle, this is a right angle triangle, this is base and this is perpendicular. Then area is half base, base is t into perpendicular. Perpendicular is v minus v naught. Then displacement or magnitude of displacement is v naught t plus half v minus v naught into t. Okay. See students, acceleration is rate of change of velocity. I have kept this form here. Then from this we can get v minus v naught is at. Now displacement is v naught t plus half. In place of v minus v naught we can write at into t. Then x means displacement is v naught t plus half at square. This is our equation 2. Okay. This is equation 2. X is equal to v naught t plus half at square. Okay. Then we will move to equation 3. But we will use this to derive equation 3. Okay. So this equation x is equal to v naught t plus half vt minus half v naught t. Let's multiply half t and opening the bracket. Okay. Then x is equal to, see students, this is v naught t, this is minus half v naught t. V naught t minus half v naught t is half v naught t plus half vt. Then displacement is v plus v naught divided by 2 into t. Okay. V plus v naught divided by 2 whole into t. V plus v naught divided by 2 and t. Outside bracket is t. Okay. Then again from this equation v minus v naught is at and time is v minus v naught by a. Then we can put here then displacement x is equal to v plus v naught divided by 2 into time. In place of time we can put v minus v naught divided by a and x is equal to, see students, 1 by 2a, v plus v naught into v minus v naught, then v square minus v naught square, then v square minus v naught square is equal to 2ax. Then our third equation I am writing here, v square is equal to v naught square, this is equal to v naught square plus 2ax. This is equation 3. Okay. Finding easier? Too easy, very easy. Okay. Then equation 4. We have to first discuss some basic thoughts before deriving equation 4. I am erasing this, again representing the motion along a straight line. Okay. Say a body is moving along a straight line. We have got all these things. These are 3 equations. Equation 1, equation 2 and equation 3. Actually, the important thing is how can we use the equation to solve the numericals. Those discussions will be very important and also useful for present and also for future competitive exams. We will discuss different forms of numericals. How can we use the equations? Also, after discussing kinematics graph, again the numericals forms will be made easier, and I will try my best to show different forms of numericals, how to approach different forms of numericals. Okay, let's consider a body is moving along a straight line, say along x-axis. The body starts from origin here. Value of x is 0, position is 0 and value of time is 0. Okay, let the body reaches at this position when time is t and distance traveled by the body is x1, this is 0, this is x1. Means in time t, let's take this time is 1 second. From 0 second to 1 second, in time 1 second the body has covered a distance x1. Okay, up to this I am completely represented. From origin to this position is x1. Let, when time is 2 seconds, let here time is 2 seconds, then the body has covered a distance x2. Okay, we may take from this position, the body has started its motion. Here initial velocity is u. Body starts its motion from origin. Here initial velocity is not u. We are taking v naught. Of course, you can take u, but usually u, v, w, etc. are taken as variables. So, I am taking v naught in place of initial velocity. Okay. So, initial velocity is v naught. When time is 0, position is 0. The body reaches, select this position is a. When time is 1 second, then distance traveled by the body is x1 to reach at position A, and time taken by the body is 1 second. And similarly, this is position B. Time taken by the body to move from origin to this position is t2, and distance traveled by the body is x2. And similarly, let's take this is position C, and time taken by the body to reach at this position is t3, and distance traveled by the body to reach at position C is x3. Okay. Then simple thoughts. I am writing complete form. Distance traveled by the body in 3 seconds. See student, this is 0 second, this is 3 second. Distance traveled by the body in 3 seconds is obviously x3. Okay, x3 is the distance traveled by the body in 3 seconds. Similarly, distance traveled by the body in 2 seconds. Obviously x2. Distance traveled by the body in 3 seconds is x3. Distance traveled by the body in 2 seconds is x2. Then the third line means third point. Distance traveled by the body in third second. I may write its x third. See students, at position B, 2 seconds is completed and 3 seconds starts. At position C, 3 seconds is completed. Means this is distance traveled by the body in third second. Means 2 seconds completed, third second starts, and here third second ends. So this is distance traveled by the body in third second, means x third. As it is shown, x third is equal to, I may write x3 minus x2. So x third is equal to distance traveled by the body in 3 seconds minus distance traveled by the body in 2 seconds. Means x third is x3 minus x2. Similarly, if the body continues its motion, let this is 4 seconds, this is 5 seconds, this is 6 seconds, and up to motion, let this is any time n second. See student, before 3 seconds time was 2 seconds, before n second the time was n minus 1 second. In 3 seconds the body has covered a distance x3. In n second, I am erasing this line, equation 3, b square is equal to v naught square plus 2ax. Okay. In 3 seconds, body has covered a distance x3. Similarly, in n second, the body has covered a distance xn. Lines are not, I am erasing all these things. I am not getting space. This is distance traveled by the body in n second. Okay. distance traveled by the body in 3 seconds, distance traveled by the body in 2 seconds, this is distance traveled by the body in 1 second. Similarly, this is distance traveled by the body in n second, and similarly, this is distance traveled by the body in n minus 1 second. So, when n minus 1 second ends, n second starts. Okay, so this is distance traveled by the body in nth second. And in similar form, as we have discussed, distance traveled by the body in third second is distance traveled by the body in 3 seconds minus distance traveled by the body in 2 seconds. In similar form, we can write distance traveled by the body in nth second is distance traveled by the body in n second minus distance traveled by the body in n minus 1 second. Distance traveled in n second minus distance traveled by the body in n minus 1 second is equal to distance traveled by the body in nth second. Okay, finding is here. Again, this equation derivation will be repeated when we will go to calculus form. I will derive the equations in two ways. This is general form. Then we will approach derivation of equations, kinematics equation using calculus. Okay. So, distance traveled by the body in n second is distance traveled by the body in n second minus distance traveled by the body in n minus 1 second left. General equation, as we know from this, distance traveled is x is equal to v naught t plus half a t square. V naught is initial velocity. Here, initial velocity, we have already taken. When the body starts its motion, initial velocity is v naught. Considering n second, means distance traveled by the body in n second is xn. In place of x, I am taking xn is equal to ut. Initial velocity is v naught. Time taken by the body to cover a distance xn is n second. V naught t, v naught n plus half a t square n square. In place of t, I am taking n second. In n second, distance traveled by the body is xn. Similarly, distance traveled by the body in n minus 1 second. Again, initial velocity v naught, time is n minus 1. In place of t, you may take n minus 1 plus half a time square means n minus 1 whole square. And as we have discussed, distance traveled by the body in nth second is xn minus xn minus 1. And similarly, xn is v naught n plus half an square minus distance traveled by the body in n minus 1 second means xn minus 1 is this much minus v naught into n minus 1 plus half a into n minus 1 whole square. Let's solve it. Xn, distance traveled by the body in n second, v naught n plus half an square minus v naught n minus v naught plus half a n minus 1 whole square n square plus 1 minus 2n. Okay. Now, distance traveled by the body in n second, v naught n plus half an square minus v naught n plus v naught minus, this is minus, this is plus, minus half a n square, then minus, this is plus, this is also plus, minus half a into 1 half a. Then this, of course, I am taking in 2 steps, you will get easier. V naught n plus half a n square minus v naught n minus v naught plus half a n square plus half a plus half a into minus 2n means minus an. Okay. Then xn v naught n plus half a n square minus b naught n plus b naught minus half a n square minus half a plus a n. The bracket is opened. Okay, now b naught n, b naught a get cancelled, half a n square get cancelled. Okay, now I may write here x n is equal to what we got, b naught minus half a plus a n. Then x n is equal to b naught plus a n minus half a. Then x n is equal to b naught a is brought common, n minus 1 by 2. This is also your equation, or you may take another step. X n is equal to b naught into b naught plus a into 2n minus 1 divided by 2. This is our equation 4. I am writing here. This is equation 3. This is equation 4. X n is equal to b naught plus a by 2 into 2n minus 1. So these are 4 equations. Again, we'll see the another method of derivation of these kinematics equations by using calculus method. This is the end of lecture 8. Again, we'll meet in lecture 9 with derivation, the same derivation, kinematics equation, derivation of kinematics equations using calculus, means by using integration method. So these are useful for your regular studies, but the approaching numericals, the form of approaching numericals, we will discuss the general form of approaching numericals as well as how to approach numericals to appear in competitive exams, means for your future NEET and JEE, etc. Thank you all. Thank you for your support, and thank you for your great inspiration. Again, thanks.